Hello, friends, and welcome to Machine Learning Data Track Part 1, the second Machine Learning Data Track. I think we should have come up with better names, but I will dive directly into what's going on with this track and how it might be different from the last one. Hello. That is a kalimba. Yeah, it is an instrument that I have literally just for streaming because it's just fun to kick off a stream with some tunes. Thank you. So my name is Will. I am a software engineer at Google. I am a coach here at Major League Hacking, and I am a massive Pythonista. I'm a big Python fan, which is going to be relevant to today because what we are doing today is basically a reintroduction to Python. But before we do that, I promised I would explain sort of what we're doing with this track and how it might be different from the other one. Steven is incredible, and I think his streams often are a little bit more like let's get into the math of the algorithm, which is incredible. And this stream is a little bit more on can we just grab some data, can we throw it into a model, and can we get kind of a cool result? And we will kind of put some meat on the bones there. But the big part is that we're going to be using housing data to try to predict housing prices, which is as someone that bought a house last year, very near and dear to my heart because every time I log on to Zillow, I get stressed out. Did I say local hack day? If I said local hack day, apologies. My full name is Will Liffert. Yeah, you can find me on LinkedIn. It is Avatar, yes. Yeah, that is, I believe it's called the Avatar's Love. It's one of the love themes in Avatar that's, I think just very pleasant and calming. And to be honest, doing Global Hack Week gets me very hyped and pumped up. And so I think having a relaxing song to kick things off is nice. Oh my goodness, Polar Void, Alvin, it's good to see you. Always a pleasure. Okay, that's so funny. Well, thank you for letting me know. That is totally an oversight. I think I traveled back in time. Global Hack Week. Boom. Save changes. Okay, refresh your screens, and it should say Global Hack Week. And that's there's one other place. Global Hack Week. Yeah, that is a blast from the past. I mean, it was a long time ago that we changed it. If this is your first Global Hack Week, yeah, originally this used to be called Local Hack Day, which is just not what it actually was, and so it was a bad name, and so they changed it, and now it's Global Hack Week. Okay, cool. So today. Let's see. I dropped in the check-in form. Today, what are we doing? We're going to talk about the project we're doing. I'm going to introduce you to Kaggle if you are not familiar already, and we will dive into all of the Python we're going to need to do this project, which is building a machine learning model to predict housing prices. That's sort of the long and the short of it. Housekeeping, I should say, I can talk fast. So if I am talking too fast for you, please let me know in the chat, and I am more than happy to try to slow down or to answer any questions. Okay, actually, the classic me streaming question. What beverage are you drinking right now? I am currently consuming some water because hydrate or dihydrate, and then I also did not have time to eat dinner today, and so I'm nursing some whey protein, which is not a thing I normally consume, but when you have to get your calories on stream, There we go. Lots of water. Hey, coffee. After my own heart. Unfortunately, I'm not doing a coffee stream this week, which is low-key tragic. Okay, I think we've vamped for long enough. It's 5 minutes after the hour. Water because I ran out of time to make tea. Yeah, that's fair. I ran out of time to make dinner, so, here we are. I have the energy of Will Smith. I will take that as a compliment. I don't think I've ever gotten Will Smith before, but he's a pretty charismatic guy, so I'll take that. Okay, so this is our Kaggle link, which we will jump to over here. So what is Kaggle? Kaggle is a platform for machine learning competitions. Oh, and let's see. Okay, yeah, you should be able to see this screen right here. And so the idea behind Kaggle is that people have an interesting problem they want to solve. So say I want to predict if people have cancer from their X-ray. And you, if you run a foundation that's doing cancer research, you can come to Kaggle and you can say, hey, I would love to just make this data public and then have all of the data scientists on the internet try to solve this problem with machine learning. And then I can get access to sort of the best solutions, which is super neat. And so that is the platform that we're going to be using, both because it's kind of fun to run this competition. So as you participate, you will build a model and you'll get to see how good your model stacks up against other people's models, which is kind of fun. But also because they give us a really cool way to write and run code. And that'll kind of be the first thing that we'll talk about. Oh, I'm so glad you were there and you remember that. And yeah, that was a lot of fun. Yeah, Kaggle, I think it's becoming my mainstay. That it's like, oh, we're doing Global Hack Week. Like, let's do a Kaggle competition because they're fun, they're engaging, and it's cool to see what people build. So our overview tab just has some general information. This has links to all of our check-ins. And so I would totally recommend you use that to get in there. You can click on the data tab. So this competition comes with some data that I'm putting out here publicly. You can see kind of what's in the data in the column section. But then you click down here, you can actually just see kind of in a spreadsheet here, all the data we have. If it feels overwhelming, don't worry about it right now. We will have plenty of time to sort of dip our toes into it. But the main tab we're going to be focusing on is code. If you click on code right here, you will see a couple notebooks that I have added. And we will really be diving into what a Kaggle notebook is, and we'll be using it to do our sort of intro to Python today. I'll say, if you are not familiar with Python at all, then this will be a good intro point. If you know a little bit of Python and are interested in brushing up, this will be great for you. If you know Python really, really well, I would love for you to stick around because it's always fun. There's always a few people that know Python really well and they want to get into well, technically, like range is not a list, it's an iterator, or like technically dictionary is ordered after Python 3.7. So if you want to get nerdy like that, I'm down for it. But we'll get into this. And then the other two tabs that I'll just touch on quickly before we really get rolling are the discussion tab. And so this is where if you have any questions about this competition, questions for me or for the community, this is a great place to engage. So you can click new topic right here to post. So in fact, I will just right now, I will say, welcome to Global Hack Week beta. I'm so excited to have you participate in our Kaggle competition. If you have any questions, let me know here or on stream. Happy hacking. Let's see, did I spell participate correctly? I think so. Cool. So now I can publish that topic. Boom. And you can come and you can ask questions here of me or your fellow hackers. And then finally, the leaderboard. So when we actually start submitting our machine learning models to this competition, you will show up here and you'll see sort of how well you're doing. And so sort of the goal of all these streams is to give you better tools to try to do better on this leaderboard. Let's see. Did I say something that contradicted technically Python uses a VM? I'm not sure exactly what you mean by that. Definitely uses a virtual environment, and there is an interpreter involved. I don't know if I would say it uses a virtual machine necessarily. Let's see. I haven't checked out Streamlit. Highly recommend Python and data. Yes, I am a big Streamlit fan. I am not a Streamlit pro, but I have dabbled in it, and it is a super fun way to get like a thing that looks really nice and polished really fast. Yeah, I totally agree with that. Okay, cool. So we've done our little tour of our Kaggle site. So now we'll click back over to code and we'll come back here. So I have parts 1, 2, and 3 kind of laid out here for us. And so if you just click on part 1, you should see all the code that I have written here. In the past, I would like write the code live on stream, but then that left me with less time to like field questions and to kind of mess with things. So we kind of have most of it already written out. Now I have a button that says edit right here, which I will click. But when you click on this, should have a button that I think says like copy and edit or fork and edit. Is that true for Python? I don't know. I believe you. I say I'm not. I have read a non-negligible but relatively small amount of Python source code, and yeah, I don't know. I say apt get install Python, and like I'm done. Cool. So this is, oh my goodness, my mate Scully. I'm so glad that you're pumped. It is so good to have you here. So I'm going to click this button, edit, right here. And this will take me into a notebook that I can play with. So if you have used Jupyter Notebooks, this is basically a Jupyter Notebook. Only Kaggle gives it to you for free, and you don't need to have any sort of underlying hardware to use it. I guess technically you need to have like an internet connection and a keyboard. But this is running sort of on a CPU that you don't need to deal with. Oh wow, wait, they're planning to phase out the global interpreter lock. That's wild. That's big. That's a deep cut. But that feels like, I feel like all of what we've done with parallelism and like multiprocessing is just totally based around the fact that there's a global interpreter lock. That's wow. Okay, we've gotten relatively nerdy relatively fast, which is incredible. But now let's get really unnerdy. So what is a notebook? If you've never used a notebook before, it is a really easy way to write little pieces of code and play around with them and test them out. So normally you write a whole program and you run that whole program. And if something at the very beginning is wrong, like you won't even run the part at the end, which can be kind of frustrating, right? So a notebook is comprised of these little cells. So right here is one cell where you can write some code and then press this little play button, and it just runs the code inside there. And you can see the first time you run it, it'll take a second to start up because they're actually behind the scenes provisioning a server for you. But after it runs the first one, everything else should be relatively fast. New tagline: relatively nerdy, relatively fast. Yeah, that's what we do here, right? That's why we're here. Why are Jupyter Notebooks so important when you're working with data? Oh, this is a great question. Love this question. Yeah, so I think that there are a couple answers, and I think in large part it comes down to the difference between sort of data science and software engineering, right? If you are a software engineer and you are building an app, then usually you are going to use some sort of beefy IDE. So like at work, I use VS Code. And the main thing that helps you deal with is lots of files that are interacting in different ways that all sort of come together to form one program that you run at one time, right? And this is good if you're kind of going to make a little tweak and then you're going to run this whole program, right? But when you are doing data science and machine learning, usually you are iterating really fast and you want to tweak one little thing and you don't want to have to rerun all of your code. You just want to test, well, if I change this one little bit, how does that work? So I think the simplest answer for me would just be that notebooks are really great for data science because they let you move really fast and they let you tweak with little things and see how things change. I think also there's an element of presentation that like when you print, you can actually, I think, export this to a PDF. Can you do this here? You can download the notebook. There are definitely ways to export as a PDF if you have it locally. So from the perspective of like putting together a report, which a lot of data scientists do, it can also be really helpful. There you go. Yeah, hard agree. Okay, so we vamped some more. So I just ran this one little cell. So now we're getting into Python. You are now looking at some Python code. And if you've never written Python before, and if you've never coded at all before, this might look bizarre to you. So let's sort of break things apart. The most basic thing that a programming language can do for you is remember a little bit of data, right? So in Python, and I think most programming languages, we call a little bit of data that you remember a variable. So my integer right here is a little box that can hold some data for me. It's like I got a box, I put the number 6 in it, and then I put a label on that box that says my integer. Another note, if you are new to programming, this equals sign is going to look a little bit weird to you. Technically, what this equals sign is doing is it's saying, take the data on the right-hand side and shove it into a box called this on the left-hand side. In some programming languages, you actually use a symbol that looks like this, which on some level is more intuitive because it's really saying, I'm asking the computer to put 6 into a box called my integer. But in Python, we just use the equal sign, which we call the assignment operator. So we can put an integer into a variable. We can also put a floating point number into a variable. So these are called floats in Python. If there's any decimal part, that's called a float. We can also put a string into a variable, which is just a bit of text, right? And we can put a string into a variable in two different ways. You can use these single quotes, or if you want to, you can use double quotes. So these are exactly the same. Usually people just say pick either single quotes or double quotes and just stick with it. I tend to prefer single quotes. I recently played around with the Space Titanic data set. It was tons of fun. That is great to hear. Yeah, actually, this is because you brought this up. A little minor plug for Kaggle. I should do the disclosure. I actually work on Kaggle a little bit. I do a 20% project at work. Kaggle is a part of Google, and so I do some work with Kaggle. So there are lots of different competitions on Kaggle that you can play around with, ranging from some that are like really educational to I just launched this big competition that is it's on using LLMs to answer science questions, which if we want to talk more about that at the end, I'm more than happy to. But back to Python, back to variables. So we've learned about three kinds of variables. We have integers, we have floats, we have strings. And the last big one that we're going to care about is a Boolean. So a Boolean is just a fancy computer science word for true or false. So we can say my Boolean, true or false. And then a neat thing about the sort of IPython notebook or Jupyter notebook setup is that if you put a variable at the very bottom, it will just automatically render that for you. So you can see what's inside of my integer, my floating point number, my string, and my Boolean down here. 6, 16.5, hello, and true. So we can run that. Oh, another tip is for you can press Shift Enter to run it without having to come and click the play button. So if you really, really care about not using your mouse, which sometimes I do, then that Shift Enter is a nice shortcut. If we have any questions about sort of Python or notebooks or variables, like please drop the questions in the chat and I'm happy to answer them. But keep questions coming whenever you have them. Boolean searching. We love a good Boolean search. Shift Enter confuses me. I don't know what's so confusing about it, bro. It's just two buttons. Shift Enter. Oh, I know. I see what you're saying. Is it's like Shift Enter goes. Well, actually, I'm not sure I know what you're saying. But I know Shift Enter if you're in like Excel goes up. Let's see. Yeah, I guess I work with notebooks way more than I work with like Word or Docs. And so, yeah, Shift Enter definitely means one thing for me. Is there any way to follow along with you? Yes, this is a great question. So I went pretty fast at the beginning, so we can circle back around. So if you come to, let's see, can I go back here? I will grab this link for you. If you come to this link, this is sort of the homepage for our competition. And if you come and click on code, and you scroll down and you come and click on Part 1 Python Crash Course, then you will see this page pop up, and you should have a button that says edit, or you should say copy and edit, I believe. And then you won't see my changes in real time, but you'll have kind of the original version that I drafted up. Great question. Okay, so we have variables. We know how to put stuff into boxes. I'm so glad you got it. That's incredible. We know how to put data into boxes. So what can we do with our boxes? Once we have data in a box, what can we do with it? Well, for integers and for numbers in general, we can do all the arithmetic operations, which is pretty standard but good. So if we have an A and a B, that's 26 and 5, we can add those numbers together with A plus B. We can subtract one from the other and store it in A minus B. We can multiply them together. So note, this is an asterisk, not an X or something, because an X could just be part of a variable name, right? So an asterisk is like the pretty standard way of multiplying. We can do A divided by B. This is a fun one. You can raise something to the power of something. So this is A to the power of B. So if B was like 2, we'd say that's like A squared, but B is 5, so it's A to the power of 5. And then you can also integer divide, which we'll chat about in a second. So what happens here? Okay, so A plus B, 31, makes sense. A minus B is 21, also makes sense. a times b, 130, also sounds correct. Now, a divided by b, this is interesting that we started out with two integers and we get a float back. And this is because Python knows, hey, if you divide a number by another number, even if the two numbers you start with are integers, you might get a fractional part afterwards, right? And so you should know that if you divide two integers by one another, you will get a float. Even if I reduce this to 25, that number is 5, which could be an integer, but it actually still says 5.1. So Python says, hey, even though it might be technically an integer, I'm just not going to worry about it, and I'm always going to make it a floating point number. And you can tell that because there's this little 0.0 at the end. Oh, here's a question. How's the sizing for everybody? Could this be a little bit bigger? I feel like this is showing up kind of small on the on StreamYard. Let me know if zooming in another tick would be helpful. Okay, what else we got? So that is normal division can leave a little bit of a decimal part. Exponents, yeah, that's a big number. I'm not going to check. I trust Python. And then integer division. So remember earlier we said there's this decimal part. Even though it's 0, it's still a float. But if we want to say, no, I'm dividing two things by one another and I want the result to be an integer, then Python will do that for us and it'll just throw away whatever the fractional part is. Oh, great to hear the bigger size is better. Good deal. So arithmetic, probably not blowing anybody's mind. We can also use parentheses. A lot of times you will have a pretty complex little math or logic statement and you will want to use parentheses. So this is PEMDAS, you know that, right? Oh, okay, this is a good question. Does the integer division round or truncate? It truncates, so it just throws away whatever is at the end. So for example, if we did 20, let's say 29, 29 divided by 5, it's technically like, what is that, 5.8? But it will just, so that, yeah, this will say 5.8, but then over here, it will not round, it'll just throw it away. Let's see. Oh yeah, feel free to tag me on LinkedIn. Yeah, I will give you an upvote in like a week when I log into LinkedIn. Yes, yeah, it does truncate. Yeah. Ooh, here's a good question. How do I find the data type of a variable? Yeah, so this is a great question. If you are coming from a language like Java or C or C++, you're probably used to doing something like writing int over here to prove that this is an integer, right? Or to tell the computer this is an integer. And Python is a little bit more, I would say a little bit more elegant, but you can ask the question, well, hey, how do I know what's in there, right? And yeah, somebody already called it out. Incredible, great work. That is the right answer. You can use the type method, which you can put any variable or symbol in here, and you can get the type of it. So if I put a in here, it'll say, yeah, that's an integer. If I came back up here and got my floating point number, however, it would say that's a float. And yeah, and what's going on here is at the time that I say, hey, I'd like you to put this integer into a box, Python just knows, oh, you have an integer. I will go find an integer-shaped box for your data because, like, I see you giving me an integer. I can just figure it out, right? So that is, yeah, that's on typing. Our parentheses work. This is, you can stare and do the arithmetic in your head if you'd like to, but yeah, I mean, 6 squared is 36. And then if you subtract 36 from 12, you get negative 24. And then if you divide all that by 2, then you get negative 12. But if you do that in a different order with different parentheses, if you just say 6 divided by 2, well, that's 3. And 12 minus 3 is 9. So yeah, that's right. Parentheses work. We proved it. There are also lots of things we can do with strings. So a very classic thing you'll do with strings in a programming language is concatenate them, which concatenate is just the fancy computer science word for sticking things together kind of end to end. So I could create a string called Will, or called my name, that holds the name Will. That's me. You could also say greeting is hello plus my name plus exclamation point. And you will notice we have to put a little space here. This is sometimes catches people off guard, but Python is not going to put spaces in there for free. If you want a space somewhere, you have to put it there. But normally this is actually not how we would do this. So you can use the plus sign on strings to stick them together end to end. But usually there's a more elegant way of handling strings. So one way that I really enjoy is a format string. So a format string is created by putting an F, just the letter F, in front of a string. And as you create your string, so most of the string looks normal, but then inside your string, you can do 2 curly braces and then put the name of any variable that you want. And Python will grab that variable that you already defined and just plop it in there. And this is, I would say, usually a sort of more elegant way to handle that for a number of different reasons. One of the big reasons is that if my name was, for example, a number, you can't use a plus sign between a number and a string. Python will freak out because, hey, I can't add a number with a string. But if you're templating it, it says, oh, you're trying to put this number into a string. Okay, I got you. I'll turn your number into a string. Let's see. Hey, Crystal. Okay, so first of all, thanks for letting me know. I'm happy that I can probably bump it one more size. The other thing that I would recommend is just come to this link and you can actually open it. You can create a clone of it. You can press the copy edit button and you can actually sort of see it in full definition on your own screen, which is probably what I would recommend if the stream is looking blurry. Yes, you can also do dot format, which you can look up dot format. There, yeah, essentially do the same thing. Cool. My favorite drink is a cortado. That is a true statement. I have a cortado basically every morning. I think it has been probably months since I have woken up and not had a cortado. Okay, little intermission. What's your favorite coffee drink? Or if you don't like coffee, you can say this is my favorite tea. Or if you don't like tea, you can say, yes, I'm Mormon. Tea. Okay, fair. Tea is good. I think the main reason I drink tea is just because I don't want to be over caffeinated. We got a lot of tea fans. Dark roast, cool. You like it just like a black coffee, like filter coffee? Ooh, those are fighting words. I am an absolute coffee nerd. Oh, tragic. Okay, Booleans. Let's go into Booleans. So Booleans are true or false. Okay, French press I actually think is an underrated coffee making method because it is so simple to maintain, right? You don't need papers, you don't need to clean anything, not bad. Tequila, okay, cool. Love that. I for one have not really gotten into tequila. I have recently gotten into rum a lot, which I don't know. If someone brings up rum later, I will probably nerd out on that. Cool. Okay, Booleans, back on topic. So Booleans are always either true or false. There's no like neutral middle value for a Boolean. And you can usually use a Boolean to describe like something that is true or false. So for example, sunny in Seattle, that's false. It's technically true right now. It is sunny outside. So I will say true. It's usually false though. And I want coffee, also true. So what you can do, and I'll just change this back to false just for the sake of the explanation. What you can do is you can use Boolean logic, so and, or, and not, in order to do sort of complex logical inferences, right? So if I run this, so this is it sunny in Seattle and I want coffee? Well, I do want coffee, but it's not sunny in Seattle. So sunny in Seattle and I want coffee is false. Sunny in Seattle or I want coffee, this is like, are either of these things true? And because I want coffee is true, it doesn't matter what sunny in Seattle is, that will end up being true. And then finally, I want coffee and not sunny in Seattle. Well, you can kind of do this piece by piece, and you can say, well, first, what is not sunny in Seattle? Well, it just flips whatever this is. So false becomes true. And then I want coffee and something that's true is true because they're both true. So we can see false, true, and true. Any questions about anything we've done so far? We've covered variables, all our different data types, and we've talked about some basic things we can do with numbers, strings, and Booleans. Okay, I love the tips on how to clean your French press. I feel like we didn't have enough coffee energy, so I'm glad that the coffee folks showed up. Yeah, I will admit, I think this is probably not the right way to handle this, but I just rinse out it and dump all of the grounds into my disposal and just like rev that thing and just, grind up all of the grinds. Um, but yeah, it probably is a better idea to put it in the compost bin. If I was a better person, I would compost my coffee grounds. Mm. Okay, cool. No burning questions on all the stuff we've talked about so far. Oh, we do have a question. Incredible. Okay. How does null get handled in Python? Yeah, so this is a great question. So if you've used other programming languages, you might have this idea of null or an empty variable or undefined or something like that. So like what happens when there's nothing in a variable, right? And I guess there are a couple things to answer. One is in a lot of other programming languages, you get null values because you can declare a variable without defining it. And you can't really do that in Python, right? There's no way to just say, like in C, you can say int my int, and like that's the whole statement, right? And you can say just create this integer value, and I won't tell you what's in it, right? But in Python, you can't do that. If you're going to say my int, like for it to exist, you actually have to put something in there, right? So answer one is like often you just don't have things that are undefined in Python because you can't create a lot of things without having a value there. But Python does give you a value for I don't know what goes in this slot yet, and that is the none value. So you can just type out none, and this is essentially Python's way of giving you an option to say I'm not sure what this value is, right? And so none is actually really distinct from true or false, right? So true is is a positive, false is a negative, but none is just nothing, right? And so yeah, none is just sort of a thing that you can use. We can get into sort of truthiness and falsiness and what things end up evaluating to true, but that's one. Ooh, okay, you've poked the bear. So I really will go to bat for Python. There are lots of good programming languages out there, right? And lots of programming languages that are really suited to a specific task, right? Like if you are doing sort of systems level, like you're writing an operating system, then like, oh yeah, Rust and C are just going to be really good for you. If you are coordinating a lot of concurrent microservices, then like Golang or Go can be like a really useful thing. If you're building a dynamic web application, obviously sort of like JavaScript and TypeScript and those scripting languages are going to be really, really useful. And yeah, I agree with this that, it depends on what you want it to do. But then here is why I'm going to come back to Python is because if you want to do any of those things, generally speaking, there is a pretty good way to do it in Python. So if you want to create a web server, you could do that in Python. Even if you want to build a sort of front end app, there are ways to do that in Python. If you want to do machine learning, you can really do that in Python. It's really the de facto language to do Python in. If you just want to do general scripting to make your life easier, you can use Python. So I think it is kind of the sort of Swiss Army knife of programming tasks. There are few things that you can't get done in Python. Beyond that, I would say that it is a relatively expressive and elegant language. I think it is becoming less elegant day by day. This is, I think, a thing that naturally happens with languages is people just cram more features into them, and the language becomes a little bit more cluttered, right? There's just like more stuff going on. But as it stands, I think that Python is a really great language. Yeah, I think that's a super fair point. Yeah, mobile with Python it's not really a thing that people do. I mean, like there are ways that you can hack it for sure, but I wouldn't recommend it to anyone. But of course, if you are backing up if you have a mobile app and you're backing it up with with an API somewhere, like yeah, write your little API microservice in Python. But no, I think that's a super fair assessment. Okay, cool. This is good. I'm glad. I feel like there is just like a relatively high level of Python nerdery going on in the stream, and I'm living for it. So please keep it coming. Okay, lists and dictionaries. So so far, all of our variables have only stored one thing, right? They've had one number in them, or one word in them, or one word is a bad example. One string in them, or one true or false value. But usually, like the reason we like computers is because they can deal with a lot of stuff at once. I can only handle a couple of things in my memory, but a computer can handle billions of things in their memory, right? And so this is, I think, a limitation if you only have variables. So lists and dictionaries allow us to deal with lots of things at once. I am going to have to get to Polar Void's thing. We're going to engage, but first I'll do lists. So to create a list, you can set it up like this. You name the list. So this is the variable name. You use that assignment operator. And you use square brackets. And inside your square brackets, you put whatever you want in the list separated by commas, right? So we have one string in our list, and then a comma, and then a second string in our list. And if you want to add more things to your list, you can use the .append method. So this basically says, take Seattle and add it to the end of our cities list. So if I run this, it'll start with Nashville and Boston, and then we'll add Seattle and San Francisco, and we will end up with this list that says Nashville, Boston, Seattle, San Francisco. Okay, so yeah, we've introduced lists. Now I got to talk about Python packaging. So I will say I generally agree. I think I generally agree with this, that the Python sort of package ecosystem could be better. I think there are a couple reasons for this, but I will try to put it in context. So one big thing about Python is that there is kind of a rift in the package space. Some people say like, hey, I just want to use pip, which is sort of like the native Python package installer. And some people say, hey, you should be using Conda. You should be using Miniconda or Manaconda or Anaconda or whatever. And I think that rift, it does make it so that like nobody is ever sure what like the nicest, easiest way to set up my packaging environment. Well, if you're confused by this conversation, we'll talk more about what packages and libraries and modules are in a little bit. But I do think it's one of those classic explain Conda in 100 seconds. Oh gosh, I'll leave that up to Alvin. No, I mean the short version is, so pip is sort of the standard, comes with Python package installer, and Conda is sort of this third party wrapper around lots of ways to install Python packages. And to sort of keep them sane. So Conda sort of layers on top of Python packages, where pip is like a little bit sort of just sort of the bare minimum sort of. This is okay. So this is actually where I was going to go, is when you compare the packaging system in Python to something like I think Rust actually handles packages really well, right? I think it's really clean. Semantic versioning is great. There's very little confusion, right? But we shouldn't compare Python to Rust, right? Because Rust is a low-level language that's beautiful and gorgeous, and I love it. But you would never do, like machine learning in Rust, right? What you have to compare Python to is to a language that is similarly high level and similarly fully featured and similarly used for everything. And I think the thing to compare it to is JavaScript. And I think JavaScript is also a mess, right? NPM, I am terrified of NPM as well, as Ratcat said. And I think you kind of have to find your own, you have to find your path with Python packaging. But once you're in your own little world, like things feel good until you realize there's a version of TensorFlow you can't get, and then you have to think about things. But for a while, you're kind of fine and safe. This is an important point to throw out, is that Conda also installs things that are not Python related, and pip is just a Python package manager. But yeah, you can also install things from pip with Conda. Yes, this video will stay on. It will stay on Twitch, I think, for like 2 weeks, so you totally have time. Yeah, I'll say, I think some streamers have a longer history. I think MLH only has like maybe a month. I don't know. I've been surprised at how fast they go away, but it will be here, tomorrow at least. But it's been a delight having you here while you were able to stay. Okay, we've gotten a little bit sidetracked, even though I live for this kind of holy war around package managers. But maybe we can jump back into Python or lists. Yeah, okay, so this is actually, I will affirm this. So I have actually, there's been a time that I have used Conda Forge because I was trying to get stuff on my M1 Mac, and that's a mess actually. And then And then when I needed to update stuff, I did have a breakdown. So +1 to that comment. Okay, this is actually, I think, the correct answer is like, no, I don't deal with a package manager. I just like, I create a VM and then do the thing and install whatever I want, and then I delete the VM and the environment no longer exists. I don't have to manage anything, right? Oh gosh. Okay, I'm gonna save text editors for the end. I do have thoughts. I will share them, and we can all fight it out. But I will save that until the end. Okay, so we've created a list. The energy today is chaotic, and I love it. So we've created a list. We were able to set it up with our square brackets, and then we could use append to add stuff to the end. And then if we want to see what's in our list, we could either just do this, where you can see the whole list here, which is kind of nice, or we can use our square brackets to index. So we start counting at 0, and so this gives us the 0 index, this gives us the 2 index, and this gives us the 3 index. So if we run that, we'll see, yep, Nashville is at index 0, Seattle is at index 2, and San Francisco is at index 3. There we go. So that's a list, and lists are really, really helpful, right? In some way, lists are kind of the bread and butter of lists and loops. Like, that's what computers do. But sometimes we have data that doesn't really fit the list model really well. And sometimes we have pairs of values, and we don't actually just have one thing to stick in a list. We have, I mean, the classic example is a key and a value. So in Python, we have a data structure called a dictionary. In other languages, you may have heard something called a hash map, which is basically the same thing, or a hash table. So a dictionary, it lets us go from one kind of value to another. So just like a dictionary, you can, if you know the word, you can look it up and get the definition. In a dictionary, if you have the key, in a Python dictionary, if you have the key, you can use it to get the value. So here, Nashville is our key, and 692,587 is our value. Boston is a key, and 684,379 is the value. So if we run this cell, we can see city populations. Yeah, it looks just like what we wrote out. We have 2 key value pairs that are super handy. If we want to find a specific value, we can index it using, instead of a number like we did up here with a string, or sorry, with a list, we can use whatever key we set. So if Nashville is in our dictionary, then we can put that in there, and we'll get the population of Nashville back out. Let's see. Someone asked, do you call that an object? I am not certain what thing I said that you asked if I'm calling an object, but definitely a dictionary is an example of an object for sure. Let's see. What's the difference between a list and a tuple? Oh, this is a great question. Okay, yeah, Polar Void hit me to the jump here, but the biggest difference. So you can do a list like this. Oh, where are we? A list, my list, and we can say 1, 2, 3. And my tuple looks pretty similar, only instead of the square brackets, we just use parentheses. And so, for example, if we do type of my list, then we'll see list. And if we get type of my tuple, we'll see tuple. Great. But as Polar Void pointed out, the big difference between them is that a list can be changed. So you can, for example, for my list, you can say, I want to update the thing at index 2 to 7. And then if we look at my list, it'll be updated. But if you try to do this with my tuple, and you say my tuple at index 2, make it 7, we will get an error. It says tuple object does not support item assignment. Yeah, yeah. So tuples can be as long as you want, but once you make a tuple, it's set. And really, the reason that is nice is because you can use. Well, really, the reason that's nice is because anything that is immutable, so a thing that can't be changed, can be used as a key in a dictionary. The reasons for this are a little bit esoteric and involve hashing, but like the way that I would put this is, say you have a literal physical dictionary that has words and definitions, and you can change the definition of a word, right? You can say, hey, this word has evolved, and I can update the definition. But if you actually change the key that is the actual word, then suddenly you don't know what definition goes with it anymore. And so this is why things that are mutable or things you can change can't be keys in dictionaries. But tuples can, because they are immutable. Yes, tuples can have duplicate elements. Yeah. Yeah, we don't actually talk about sets in this intro, but sets are pretty great. Decks are pretty good. Counters and default dicts, all good stuff. At some point, I'm going to do a just like a whole week just on deep diving into little details of Python. We'll do like intermediate to advanced Python. That could be fun. But so back to dictionaries. Incredible questions, by the way. I'm living for the questions. So if we want to get a value in a dictionary, we can index it with the key that we set. And then to add a key value pair, we do it like this. So we don't have like a dot add function for a dictionary. I think technically there is a dot set, but forget about that. But what you do is you kind of act like the key already exists, and you just say, this is what I want to update it to. So if you do this, we will see our dictionary is now real big. All right, Polar Void. I will send you an email if this thing ever happens, so that you can pull through. It'll be you and me, and actually, there have been a few folks that I feel like would vibe with that. Another important detail for dictionaries is that if you want to get just the keys or just the values, you can use dot keys or dot values. So if I print these out, you will see dict keys and dict values. So technically, this is not a list, but it kind of functions like a list in most ways. And you just have sort of this, this collection of all of the values or all of the keys and all of the values. Any questions about dictionaries and lists? Here's another one. So lists are often thought of as being ordered, right? Like if you put a list in a specific order, it will not change. This is also true about tuples. If you put it in a specific order, that's just always the order. And historically, dictionaries have not been ordered. So you put your keys in a dictionary, but like the keys could be anything, and it's not like they're going to be stored in a specific order, and you shouldn't depend on that, right? And then technically in Python, like recently, a recent update to Python, kind of recent, they actually made dictionaries ordered. So kind of like how in the dictionary, like an actual English dictionary, say, everything is in alphabetical order. They kind of do something like that now. But usually, besides just the factoid of being able to do a gotcha with someone, be like, oh, our dictionary is ordered or unordered. Technically, they're ordered. But in general, you shouldn't think of them as a thing where the order matters, because really you should just depend on, I have a key and I can get a value back. That's what I'll say on that. About what you said earlier, is being immutable the only requirement for being used as a key in a dict? Yeah, so technically the requirement is being hashable, and usually, usually mutability is like the big difficult one. But you can actually implement your own like, if I am being hashed, like this is the data that should be hashed. So usually, like if something is going to change, then that means that its hash would change. But there are also cases where, for example, two things are. I mean, usually it does come down to immutability. It is technically possible to make something that is mutable that you have just overridden the hash function. Okay, we can explain hash. We're drifting dangerously close to like we're just going to do data structures and algorithms live on stream, which is, I mean, it's kind of what we're here for. Let's see. Apologies, just checking a specific thing. Yeah, okay. So yeah, this is a lot. So hashing. Oh yes, I can share. This is the so this is the link that we're currently hacking away at, and then here is the check-in link. Actually, you know what? Okay, I'm gonna put a pin in hashing. If we have time at the end, then we can dive into hash functions. because they are incredible and like the basis of like most computer science, well, a lot of computer science, they're the basis of a lot of interview questions actually. But yeah, we will charge ahead, and then if we have time at the end, I will do more time on hash functions because they're great. Cool. Okay, ifs and loops. Yeah, let's do a little Python. I mean, hash functions are Python, but yeah, we'll get back on track. So ifs and loops. So far, all of the code we've written has run sort of directly in a line exactly as we have written it, which is normally great, right? You tell the computer what you want it to do, and then it just does it. But sometimes you want the computer to sort of make a decision based on some information that it has access to. So, for example, I could declare a Boolean called pineapple belongs on pizza, which is, of course, set to true because that is a true statement. Fight me. And then I could say, okay, I want the computer to only print out this little bit of text if pineapple really does belong on pizza, which I don't know what that's doing there. And a couple things here. So one, it's going to say, so we write the word if, and then we include our thing that can be true or false, right? So after if, you will always have a Boolean expression. So this is just literally a variable that holds a Boolean, so that counts as a Boolean expression. And then we have a colon, and then we do a tab. So the tab tells Python whatever has a tab in front of it kind of belongs to this if statement. And so if I run this, because this thing is true, we end up printing out that text. If we were in some kind of spooky parallel universe where pineapple did not belong on pizza, then it would not do anything, right? But just to build home the point, or hammer home the point that you can really put anything in here. If you wanted to, you could put some other logic, and you could print out that. Oh, that's not right. Lowercase x. And so we get a 5 here because we did a little bit of logic. That's an if statement. Wow. Okay, the haters are really out today. There are a lot of people that are hating on pineapple on pizza. I'm telling you, a sort of like crispy charred cheese that has like really deep savory flavors, and then a really like bright tart pineapple note, like that is a really good flavor combination, and I don't know why people are hating. Okay, thank you, Alvin. You're my favorite. Okay, cool. Okay, banana pizza I think is cursed. I'm sorry, I can't get on board with that. Like in general, I think people that like weird pizzas are oppressed, and so I do want to stand with you. But your fight is not my fight. So that's an if statement. We can also do sort of comparisons and logic inside of our if statements. Okay. This is not actually on GitHub, but you are welcome to copy and edit and make that, put that into your own. So inside our if statement, I said we need a Boolean expression, which can either be just a Boolean itself, or you can do something that turns into a Boolean. So when we do a comparison like this, so my age greater than 16, Python will look at this and it will actually turn this into a true or a false. So I'm 27 years old, big reveal, plot twist. And I can say, if my age is greater than 16, then I'll print, you can get a driver's license in the US. And if my age is equal to 22, then I will print out, I don't know about you, but I'm feeling 22. Thank you. Yeah, we gotta keep the Taylor Swift references in there, you know? So here, this becomes true, and so it does print out, I can get a driver's license in the US. But this is not true. My age is not the same as 22, and so it doesn't print that out. But if for example, this was Polar Void's age, we said, happy being 22, that's pretty incredible, then we would get, oh, that's fun, actually. We have that there. How about that? Then it actually prints out both. Yeah, there you go. We get, I'm feeling 22. Oh, okay. Of course. Great question on the why are there, I mean, I guess the underlying question is why are there two equal signs here? And earlier we said that a single equal sign is the assignment operator. And the reason is because that means that we now need to figure out something else for actually checking are two things equal. and we use double equals. So if we just had a single equal sign, it would actually throw an error and say no, this does not work. And you could use the walrus operator, but yes, it does throw an error. Yeah, I'm like 100% sure that that Alvin knew that and was just building discourse here, you know. Cool. And then of course, if we had someone, I don't know if anyone in the crowd is 20 years old, but if you were the person running this, or sorry, not 20, if anyone, well, okay, I don't know if anybody in the crowd is 15 years old. I imagine that's like on the lower end of the age spectrum here. Then nothing prints. Ooh, okay. So this is good. This is again getting into like the sort of moderate to advanced Python. Yeah. So if you are familiar with the difference between passing something by reference or value or address or reference, then this is for you. If not, don't worry about it. It's not going to affect your life too much. But the short answer is that generally speaking, you are passing primitives are by value. So if I have like one integer that I'm throwing in another variable, that is by value. If you have an object, then that is going to be by reference. You are going to get I believe, oh gosh, what does Python call them? There's a word that is used in Python that's not used. I think it might just be reference. I think sometimes they actually use the word view, but yeah, you basically have a like if I passed a dictionary into a function and changed that dictionary, that would be the same dictionary. It wouldn't be a copy of it. Yeah. Someone's asking for the thank you for chipping and answering that question. Appreciate that. Boom. Let's see. Loops. Okay, so loops, I said earlier, like 80% of computer science is lists and loops, just because a computer is a thing that can do the same thing a bunch of times, right? That's what a computer is. And loops let us do that. So if we had a list, I think this was from the last time I did the stream, but here, let's just call out some of the more active people on stream. Is this Revrelt? No, Revrevelt, maybe? If you have a better way of pronouncing that username, let me know. And then, hey, Crystal. And you know what, Polar Void, you can be included. I'm gonna have a hard time spelling it correctly though. And then Asmam Hadir. I have a list of these people, and let's say I want to welcome everybody to the stream, but that would just be too tiresome to say everybody's name. So I could collect a list of everybody's usernames, and then in a loop, I can create a list of everybody's username, and then in a loop, I can loop through and tell Python to welcome everybody to the stream. So the way we do this is you have a list or something that is iterable, and then you say for hacker in hackers. So this is our list. And then this is just a holder variable. So this is just saying, I want to take every item in this list and have it take turns being hacker. And when every item in the list hackers is taking a turn being hacker, then I want to run this code. So for the first time, Revrelved is hacker, and we print that out. And then hey, Crystal is hacker, and we print that out. And then Polar Void is hacker, and we print it out. And so you can see we got to do some work for everybody relatively quickly and spit that out. You could also do some logic in here if you wanted. So I could say hacker upper to make it uppercase, and I could say loud hacker. If we did that, then we would get everybody in all caps. Thank you, The Grinch Watches, for throwing that out there. Oh, this is a great point. So after you are done with this loop, so it has been rerunning and reassigning values to hacker. And then if at the very end you printed out hacker, it would actually just show you whatever thing was stored in there last. And this is what would happen in a lot of languages. But so yeah, it actually does end up defining this in the global namespace, which is a little bit weird. I think this is one of the less intuitive things that Python does, because I generally expect, like, hey, that variable just kind of only exists in the context of this loop. there are some rare, yeah, no, honestly, Asmam Hadir, I actually like am with you on like, I kind of feel like it should be undefined, right? Yeah, but it does actually grab the last thing. Oh gosh, this is an aggressive claim that I feel like maybe on some philosophical level might be true. It's not literally true. Like there are definitely ways that you can have, like scoping exists in Python. But yeah, I'm gonna have to get dive back into scoping in Python because like I don't know actually if I like okay, what if I print loud hacker? Does loud hacker define globally? Yeah. Interesting. Let's see. Yeah, that feels cursed. I don't know. I don't love that. But yes, today I learned that loops don't have their own scoping, which feels wrong. Well, when we get to functions definitely have scoping, so that would be nice. So we used a loop on a list. We can also use a loop on a dictionary. So let's say we have a list of people and their ages. And when we iterate through a dictionary, what we end up getting are just the keys. So in this case, we will get the first key will be Will, and the second key will be Richard, and then the third key will be Benjamin Franklin, and we print those out. And then we can update the values inside our dictionary by saying ages key +1. This is one we didn't touch on. When you have a variable, a normal way to add 1 to a variable. So if I said my num is equal to 10, and we want to print out my num at the bottom, I could say my num equals my num +1. This would be sort of like a quote unquote normal way of doing this. But because you end up doing this kind of thing a lot, Python lets you just say plus equals, and it does the same thing. Yeah, Python is actually, okay, talk about all the different things that you can do with Python. Yeah, Python web scraping is like Python web scraping in Python is great. Okay, this is totally off topic, but let's see. Do I still have this running? It'd probably take a second to load. One of my recent projects that I really need to make better because there is just way better machine learning out there is called yogurt.click, which I think it's set up on GCP in a way that it scales down to 0 when you're not using it, and then it needs to wake up, which is great. But okay, on web scraping being illegal. Yeah, there are lots of cases where things can be like you want to do web scraping and then like, wow, I got to read a terms of service, right? Because a lot of things will have a lot of sites will say, if you do this, like read the robots.txt, be a good citizen. If you're going to violate that, use a VPN, all that good stuff. Okay, here it is. Yeah, here's my project from a while ago where you can grab that uses some element of web scraping. But so you can grab, let's grab an article from The Verge. Let's see, what's a good article? Oh, is it The Verge? The Verge. Okay, cool. Here's a good article. And then we can post it in here. And then through scraping and some other things, you can get a little quiz, a little fill-in-the-blank quiz. So enjoy that. Yeah, websites are making it harder to do web scraping, and I understand that, right? I think for good reason. And there's definitely there's a push and a pull, right? I think there's a real way in which I might want to publish something, and any human that wants to read this, I'm cool with that. And then oh yeah, a Python script that will slurp it up and do God knows what with, I might feel worse about that, but. Yeah, I'm not a lawyer, and we're would you might would I might I don't know. Yeah, Reddit is not happy right now. There was a solid couple months where it was oh, all of the internet is falling apart, but Reddit seems fine. And then Reddit was hold my beer, we'll mess some shit up. Yeah, so I'm actually working on this is a greand question. Right now, it is relatively, I would call it, it's a small language model. It's a very dumb little tiny language model. And I'm working on another version that actually just uses a proper LLM to do it. which I think will be better. But yeah, need to ship that out, which is, I don't know, personal projects. You set them down and then, and then it's 6 months later and you haven't touched them. Where can we get data for our projects if not through web scraping? This is a great question, and you've activated my trap card because a great place to get data is Kaggle, actually. So if we come over back to our homepage here, in Kaggle, you can come over to data sets right here. And there is an insane amount, excuse me, of open data sets that people have said, like, I'm comfortable with this data being used by anybody, right? And they will have their, so here's like a bunch of NASA data. They will have a license, so you can go and see exactly what am I allowed to do with this. But yeah, there are just, I mean, I think millions upon millions of data sets here for free. There are also other really great sources. But yeah, that's on how to find data. Also, it's like a real thing that, oh yes, if you have a novel way to get interesting data, like that's a business, right? Like you can make money off of that for sure. Yeah, governments are actually usually a pretty great way to get data because they often will release it publicly and let you do whatever you want with it, which is pretty rad. Okay, we did loops. We looped through some lists. We looped through some dictionaries. Any questions on that? If we have no questions on looping through lists and dictionaries, we could talk about functions. So a function is basically a way of packaging up a little bit of code for us to reuse later. The other analogy that I like with functions is it's kind of like a recipe, right? If I have a recipe for making a cake, that recipe will tell me, here are the things that you need to put into this recipe, right? It'll give you a list of inputs. Then it'll give you a bunch of steps of what you're going to get. And then at the very end, it will say, like now you have a cake, right? There's a thing that comes out of the recipe. And notably, you can use that recipe again and again. And that's kind of what a function does. So every function in Python starts with the def keyword, and you give it then a name, and that name needs to be unique. Then you put these parentheses here, and this is basically your ingredient list. So like if this was, a recipe for a cake, you might say flour and eggs and sugar. But in our scenario, we're saying our inputs are foo and bar. So then inside the function, you can do some logic, right? So this is doing some computation here. And at the very end, you can use a return statement that says sort of, this is what you get at the end of the recipe. And some of these features are actually not actually necessary. You can have a function that has no input. You also can have a function that has no output. But you have to have a name and the def keyword. We also use the same pattern where everything that's indented, everything that has this tab here, is part of the function. But then if I came down here and did some other stuff, this would not be part of the function. So then we can call this my adding function, and we get 8. So now, if yeah, true. I do live here to trigger some math majors. No, in another life I was a math major. So now, if this surprises me, I will be absolutely shook. But this variable, my sum, should not exist outside of this function. Okay, thank goodness. Thank goodness I did not. I was just not erroneously believing that scoping exists at all in Python. But so what happens is inside this function, this is kind of your own little universe, and nothing that happens inside this function really can affect the outside of this function. That's not strictly true. There are edge cases here. But yeah, like my sum, I create this inside my function, and then I return it, and it just is a number that turns out to be 8. So this doesn't exist on the global scope, which is great. That's functions. This is obviously kind of like a silly function. Here's a fun one. You can call functions from inside themselves. So like a classic example here is to define Fibonacci. So if you're not familiar, is that how you spell Fibonacci, or is it 2 C's? Fibonacci. Oh, this is embarrassing. So the Fibonacci sequence is usually defined to be you start with 1 and then 1, and then you add the two previous ones. The two previous numbers to get the next number. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 8 plus 5 is 13, and so on and so forth, right? One B and two C's. Okay, we got there. Thank you. It takes a village to spell Fibonacci, as I like to say. And so we have our this is the Fibonacci sequence, and it goes on forever, and it shows up in nature, and it's very cool. But what if we wanted to write a number that, or a function that said, if I give you like a number 3, I want you to tell me what the third Fibonacci number is. So if I say 3, you should tell me 2. If I say 4, you should tell me 3. If that premise doesn't make sense, like, don't worry about it too much. But a classic way that you could write this function, there are other ways, and frankly, there are better ways. But one way you could write this function is you could say, so if n is coming in here, and if Fibonacci returns the nth Fibonacci number, then one thing you could say is, if n is equal to 1, return 1, and then else take Fibonacci, or really you could say if n is equal to 1 or n is equal to 0. We'll zero index here because both of those are 1. Otherwise, you can take the Fibonacci of n minus 1 and add it to the Fibonacci of n minus 2. Oh. Okay, I'll just spell it out again. And then we'll return that. And if this is bending your brain a little bit, that's okay. Recursion does get kind of hairy for lots of people. But then we can say Fibonacci. So a simple one, like, okay, if we say Fibonacci 4, we get 5, and that makes sense because this is the 0 index, this is the 1 index, this is the 2 index, this is the 3 index, and then this is the 4 index. But then really easily we can say, what about the 400th Fibonacci number? And you will see this actually is taking a long time because recursion is in many cases just like a famously inefficient way to code something. There are cases where recursion is actually really, really nice and helpful, but there are a lot of cases where it will you'll get sort of recursive blow up. Yeah. Because another way of putting this is that for every time you have to, like, for every time you have not reached your answer, you have to make 2 additional calls to this function, right? So this is probably actually going to just be a disaster. So let's delete that. Okay, maybe let's try the 20th Fibonacci number. Okay, that was pretty fast. We get 10,946. Could you have called my adding function before you defined it? Yes, yeah, that is basically correct. As my dear, good answer. Yeah. Also, this is actually a case where a notebook and cells make things a little bit funny because, like, here it's like, okay, Fibonacci is defined here, but I could come up here and call Fibonacci 4 or whatever. And while this happened earlier in the notebook, because I've already run this cell, it's like it almost is like this cell is above it, right? So notebooks make the ordering of things weird, but yeah, generally you have to have a definition for a function before you call it. Yeah. But yeah, Asman Hadir, good answer. Okay, cool. We've done functions. We did recursion, which I normally don't get to in this one, so that's fun. Libraries and pandas. Okay, so we talked about our little holy war about package managers. But actually, thankfully, a lovely feature about Kaggle is that usually you just don't have to deal with installing packages. Sometimes you do, and when you do, I actually recommend pip, to be quite honest. But there are a lot of packages that are just built in. So a classic package is random. So packages are somebody else has written some useful code for you, and instead of rewriting that code yourself, you can just go and borrow that and use it yourself, right? So in the same way that we talked about a function is kind of like a recipe, a library is kind of like going to the library and checking out a cookbook, right? You're like, somebody else has already taken the time to write a bunch of recipes. I just want to go and borrow their recipes and use them myself, right? And the way we do that is with the import statement. So import random just says, hey, you know, all that set of recipes called random, I would like to use those here. So then from that recipe, from that cookbook, kind of, we can name the cookbook, and then we use a dot, and then we list a function from that. And this is actually kind of a bad example because it's the same. But so the random library does have a function called random inside it. But like, okay, there's another one called choice. So if you have a list of stuff like 1, 2, and 3, then choice will make a random choice from your list, which is kind of nice. There's also one called random. That if you call that, it doesn't take any inputs, and it just gives you a random number between 0 and 1. And that is useful if you're trying to, if you're trying to build a game and you want the opponent to have a little bit of randomness in what they do, then that is a great function to use. If you ever want to know about what's inside a library that you've imported, you can use the dir method. It's not great in my opinion. It will tell you everything that's defined in that function or in that library. And some of them are actually pretty, like you can get in here and you can see, oh yeah, we used random, we used choice, and you're like, oh, there's also one called choices. That's kind of neat. But this is just often kind of overwhelming to me. And so often if I wanted to know like what's inside the random library, I would just go and Google Python random library. And then you can get sort of some nicer documentation on all the stuff in there. This documentation also can be overwhelming sometimes, but teach their own. Do we need to download anything for libraries? So for most libraries that we will care about, the answer is no. This is the thing that Kaggle does well, is just so many things come pre-installed. If you wanted to, then there are ways to do that. And normally it's going to look like, so we talked about pip. Inside a notebook, you can use the exclamation point to run what's called a magic command, and that is essentially just running something in the underlying computer that is running your notebook. So if I wanted to run pip, I would do an exclamation point, and then I would say pip install, let's say NumPy. Now NumPy should already be installed, and so it'll probably just say, hey, this is already installed. Yeah, okay, so it says requirement already satisfied, and there it is, because NumPy is already installed here. But yeah, if you ever do get an error saying that a library does not exist, then this would be kind of the command that you'd want to run. Cool. Another cool library called matplotlib. We use this one a lot. I will run this so we can just define. Oh no, that's not what I meant to run. Matplotlib is just a graphing library. So if you just have a little bit of data and you just want to see what that looks like in a graph, matplotlib is your friend. So the way we import this is import matplotlib.pyplot. This is technically a module inside the library. And then here you can give it an alias. So because matplotlib.pyplot is just kind of a long name, saying as PLT is a pretty standard way of just putting this whole thing, giving it sort of another name, almost like assigning it to a variable. So here we can have one list of numbers and then another list of numbers that is x squared, and then we can call plt.plot. So plot just does a line graph for you. And if we run that, boom, we get our little quadratic little curve there. Very fun. Then the big one that we will be messing around with a lot this week is called pandas. So pandas is basically a way of interacting with spreadsheets in Python. So if you ever use like Google Sheets or Excel, you have kind of this nice little array of data that you can mess around with, right? And in pandas, you are able to import that kind of data and work with it in a pretty Python way. So here is, you don't need to pay too much attention about it, but here is a dictionary called raw data, where every key is a column, and then the value is a list of the data in that column. So we have a state column that holds all our states that was defined up here. And then we have an abbreviation column that holds all our abbreviations that's defined here, and population and number of Starbucks. And so to turn it into a data frame, you can say pd.dataframe and then pass in your raw data. We'll find other ways of doing this as well, but this is sort of the classic way to, or the one way to get data into a pandas data frame. So here we have just a view of our little spreadsheet here, right? Let's see. Yeah, so this is a good question. So there are a couple things that people call this Python, idiomatic Python, and this just means sort of like the normal way that everybody does it by convention, right? So, so matplotlib is basically always imported as PLT. Pandas is almost always imported as PD. TensorFlow is almost always imported as TF. There are a few more like this. NumPy is almost always imported as NP. And usually these are the libraries that you use a ton, and so you just want to save a little bit of time. And those are things that you just kind of pick up when you see enough other people doing that, then like, okay, yeah, you'll end up doing that, right? But I wouldn't worry too much about it. If you don't want to use aliases, you don't have to. And if you want to just for yourself, like there's nothing wrong with that. Kali has that many Starbucks stores. Yes, it does. Let's see. What does DataFrame specifically do? Yeah, so this is a good question. Yes, like one way of thinking about this is it kind of makes like a spreadsheet like you would see in Google Sheets. The other way of thinking about it is that when you make a data frame, it is going to sort of reorganize it and remember what's really important about it. So like, for example, it's going to do a little bit of pre-work where like, if it notices that, oh, hey, this whole row or this whole column is just numbers. Oh, I can store this efficiently as just numbers, right? And it says, oh, this row is just strings, but every string is just 2 characters. Oh, okay, I only need to store 2 characters worth of data for this whole column. And so it will notice these little things to be able to speed up things when you do it later. And kind of how you interact with that does kind of feel like, yeah, it almost just made a spreadsheet for me. But yeah, I don't have like I don't know, I'll have to think about a better metaphor or better ways of explaining that. But yeah, it's kind of it loads it up in a way that makes it fast to deal with. So if we do df.head, that just shows you the first couple rows. But if we just print out df, then you can see everything in there. So this is sort of the whole data frame with all of our states and abbreviations and population and number of Starbucks. You can also pull out a single column, just like you would for a dictionary, which is very neat. So you get just the number of Starbucks. And then you can do a lot of data analysis kind of for free. So with that column of number of Starbucks, we can get the mean just by saying .mean. We can get the standard deviation just by saying .std. We can get the min and the max. So if you run this, so the average state has 854 Starbucks. The standard deviation is 828 Starbucks. The smallest state has 326 Starbucks. And the largest state, or the most Starbucks state, has 200 or 2,821. Yeah, that is a lot of Starbucks, isn't it? Each individual column also kind of works like a list, so you can loop through it if you want. So for state in states, or in our state column, you could print out state is a state in the U.S. And this will give us all of those sentences for all of our states. Okay, here's a good question. Can you do df4 to get the 4th column? And the answer is no. What you can do is, so yeah, DataFrame does not by default, if you just try to index in it, give you anything actually. Because there are so many different ways that you can think about getting into, like, is that the column? Is that the row? Is that the individual cell of data? There are lots of things that could mean. And so it forces you to be a little bit more specific. So one thing you could do is if you wanted the 4th column, you could actually just get the list of columns and then just take the thing at the 4 index there. Oh yeah, there aren't 4 columns. Okay, you could do the index 3 column. So you could do it that way. Yeah, because it's multidimensional, indexing gets a little bit weirder. We can also use these, because these columns individually are kind of like lists, we can also use them to make a graph. So just like we did before with matplotlib, but this time with population and number of Starbucks, you can plot that. And so you can see There's generally a positive trend that if your state is bigger, you have more Starbucks. But it's not perfect, right? Like California is way up there on both of those. And then I wonder what that second to smallest one is, or that third to smallest one is. Come back and look at our data. Okay, I guess, yeah, Illinois has kind of a lot of Starbucks for how many people live there, which is interesting. This is data analysis. We are data scientists. We just learned something. You can also do filtering. And I think this is probably, I think there's a little more stuff in here, but I think this is probably the last thing I'm going to touch on is filtering. Oh, maybe we'll do filtering and creating new columns. So when you do a comparison with a column, if we just do DF population greater than, is that 2 million? No, greater than 20 million. We will get a list of trues and falses. So this is basically a new column that's just trues and falses. But we can now use this list of trues and falses to filter our overall data frame. So if we use that list of trues and falses as our index, then we'll only get out the ones where that's true. So you can see all of these all have a population greater than 20 million. Greater than, wait, no, is that? Yeah, greater than 20 million. So this is a really helpful way of filtering it. How many Starbucks does Vermont have? Like 5. Let's check. How many Starbucks in Vermont? Only has 8 Starbucks locations. Wow, that is nuts. That is, yeah, that's pretty crazy. Huh. So in addition to being able to do a filter like this, we can also create a new column. So like, what if we wanted to do the number of people per Starbucks? We could say population as a column divided by the number of Starbucks as a column, and we would get this new, we could define a new column, people per Starbucks, and we would in fact get a new column in our data frame called people per Starbucks. So there is 14,000 people for every Starbucks in California, but there's a whopping 3,000 people, or sorry, 31,000 people for every Starbucks in Florida. Yeah, eight Starbucks, a super high number. Yeah. Let's see, how much more do we? Okay. We'll finish this out because then we should have time to talk about like the competition and submitting and stuff. Okay. What if we just want to analyze states that have Starbucks for every 3,000 people or fewer? So now we could say, we could do that filter where we're comparing people per Starbucks. When is that less than or equal to 30,000? And we can filter that. And then we could create a new column where we say caffeinated equals highly. Now, we are getting a little bit of a warning here. And this is actually because this is something that someone brought up earlier, is the does it pass things by reference or by value? And so because Pandas wants to be efficient, it doesn't actually copy over all the data when you do a filtering. When you do this, it actually just sends basically a pointer to the data that this is true for. So when you filter something out, you're not actually getting, this is not a whole new Pandas data frame. In fact, if we do type of this, oh, that does say data frame. Let me say DF. What does that say? Okay, so technically it is considered a data frame, but it's a data frame that doesn't actually have data of its own, right? At this point, it is actually just pointing to the data inside DF. And so when we try to actually mutate that and we say, okay, I want to create a column, it says, wait, you're actually trying to change something that is itself just a slice of a different data frame. And so you'd probably want to actually update that original data frame instead, is basically what it's saying. So if you want to do a filtering and then mess around with it, then you can always throw .copy at the end of your data frame. And this now gives us a whole new data frame that we can mess around with. And we can set caffeinated equals highly. And there we go. We have our most highly caffeinated states here. I am not going to get into my favorite things because I want to have a minute to just chat about the competition and how to submit. Let's see. Polaroid said, is there an easy way to see what the structure of a type looks like? That is a good question. So I mean, so usually the answer to that is the method dir. So for example, if you just want to see, well, what's inside this object, then you can do dir that thing. You can see all of the different little properties and methods on that thing. This is usually overkill because it's like, yeah, that's like a lot, right? But that is the only sort, or that's the main universal way to see that, to see sort of like what's inside this object. If we omit that dot copy, will we still modify the original one? Yeah, so with this, that is a great question. So we get this warning. Let's check. Okay, yeah. So when we modified this, we actually did not modify the original one because it threw this error and it said like, no, I don't think that's actually what you're trying to do, right? If we look at this one, yes, we already overrode it. Let's see if we run this again. We actually do get it. So we did actually succeed in setting this. It's just kind of warning us that, hey, you still have a slice into this original one. And that makes me, as pandas, feel kind of weird because I feel like you should be just modifying your original data. But yeah, good question, Fizz09. Radical. Okay, so we've done our little refresher into Python. And tomorrow, we are going to really get into machine learning and data analysis is the big thing we'll be doing tomorrow, exploratory data analysis. And we will actually make a submission. But I want to just hop into sort of what this competition looks like. So if we come back here and we come to data, we have just click on train.csv. We have a large data set that you can ingest as a pandas data frame. That would be really nice. With a bunch of information about different houses, right? We have the zip code it's in, we have the city, the state, when it was sold. And if you zoom forward or slide forward, we have, what is this? Yeah, the number of square feet in the living area, what type of building it is. Is it like a single family home or is it a condo or a townhome or something like that? And then at the very end, does it filter this out? Boom, price. We have the price that it was sold for. And so the object of this competition is to, based on all of this information, predict what the price ought to be. And we are going to look at lots of different ways to do that in the coming 3 days. But ultimately, you are going to run a notebook that takes in some input data and then produces a set of price predictions. And that's sort of what a submission is. So if you go to code over here, it's thinking. Oh, here we go. Boom. And I believe, let's see, do we do this actually in exploring our data? This is a sneak peek. If you want to just look at what we're doing tomorrow, you can. No, we don't. Okay. In that case, we'll go to building a simple model. And if you scroll down to the very bottom, you can see that we... Oh, do we actually submit? Okay, I might be playing myself here because we don't actually have one that's published that actually submits. Yeah, I don't think we do. Okay, in fact, here's what we'll do. We have almost 30 minutes left. I'm going to create a new notebook that is just on submitting. Because we now know how to use pandas, we can make this work. So I'll call this part 1.5 submitting. Okay, so we are going to import pandas as PD. And if you come and click on this button over here, you will see that our input data is already living here for us. And if you come and you grab test.csv, you can type PD from CSV and just paste that path there. So if you come over here and just click the copy button on train, you will get a data frame. Oh, no. Is it read? It's read CSV. Apologies. And so this is another function of pandas that lets you just slurp up a file full of data and then gives you this nice little view. So this should look actually really similar to what we saw on the data page. And this is our training data. So in machine learning, we'll really get into this really tomorrow and the day after. But when we're getting into machine learning, we're usually thinking about having some labeled examples, and then from that labeled example, trying to learn how to predict new things. So like the classic example of this is ChatGPT, right? ChatGPT has read a bunch of text where it knows what comes next. And then when you're talking to it, it's just trying to predict what should the next word be based on all of the things it's seen before. And so your training data here is this is all of the stuff we've seen before. So you can see that it has all of this information and, oh, this is test. And at the very end, it has price. So these are labeled examples that we have. But if you copy this, let's call this train. And then if we copy this whole list and we change this to test, or this whole, that guy. And if we look at test, it looks really similar to train. The only difference is there's no price at the end. So our test set is stuff where we don't have the actual sort of answer or label to the question. So ultimately, to make a submission, you have to take this training data set, train a model, and then make predictions on the test set. And I want to walk through, like, I'm going to pick like a dumb way to approach this. And let's say, what if we said every home is 100K? And we just say, I'm just going to predict that literally every home is worth 100K. So now what we can do is we can take our test set. We can say price is just equal to every home is 100K. And then if we look at test again, we will see, okay, now every home has a price, right? We have made a prediction on our test set. Then to submit, I can grab test and then just select the columns of ID and price. And this becomes our submission. So we can look at our submission, and our submission only has IDs and prices. And actually, if you come back to, we can come back to the main page. If you go to data and you scroll down and see sample submission, this is what our sample submission looks like. It has one row of IDs and one row of prices. And obviously, these prices are a lot different, right? But we're just saying everything is $100,000. All the homes are the same. Yes, I can share this as well. As soon as I can, yeah, I'll share it now, and you can see whatever I have so far. Boom. So it should pop up in just a second. And to be clear, like just saying every home is worth $100,000, that's not machine learning, right? Like that's us making a random guess, right? So now once we have our submission, we can say to CSV, and we'll want to call our submission.csv. And then we're going to want to make sure that we only include our data and not this index on the side. And so I believe we can say index equals false. And so now I will actually share this again, or I guess save it again. And the way that you can test to see if this worked correctly is inside our output directory, you should see submission.csv. And you can even download this file and open it just to make sure it looks right. And cool, we have ID and we have price. And so this should be ready to go. This is not the, this is obviously not a great solution, but it is a solution. It's a valid solution that we could submit. So when we're ready and we're feeling good about this, we can click this submit button, and every day you can submit something 10 times. So this is a relatively high limit. I want you to, if you want to play around, like try as many things as you want. And when you click submit, it'll say queued and it'll start running. And so now Kaggle is running your submission to see how well it does. And once it is done running, we should be able to see, it'll say successful, and then we should be able to see how well we did. Is there time to talk about how to format the outputs and charts? Are you talking about like formatting matplotlib charts or like graphs? Because I could be down to do a few minutes on matplotlib formatting. Okay, cool. It's complete. So if we come over here, we should be able to see. Okay, cool. So our score is 251,119. Now, tomorrow, the day after, we'll talk more about exactly what that means. But sort of the and blush, I guess I probably won't show up on the leaderboard. Yeah. So the way that we're scoring this is we're basically saying, on average, how wrong was your prediction? So in this case, my score is 251,000. That means on average, I was $251,000 away from the actual price. So that's like pretty bad, right? If you want to build something that's like good at predicting, ideally you wouldn't want to be off by more than, $10,000 or $20,000. So this is like if you ask me how much that house is worth, and I said like, yeah, I think it's 500,000, but it might be worth 750,000, and it might be worth 250,000 because like on average, I'm getting it 250,000 wrong. You wouldn't really care about my prediction because you're like, you don't actually know, right? You're just making stuff up, which is, of course, what we did here, which makes sense that our prediction was so bad. Yeah, so training your model with the test set is exactly what we're going to do. And it's what we're going to get into. I think mostly tomorrow, we will be doing sort of just data analysis. But then at the end, we might actually build a model and train it on the train set. And then, you're saying what if someone trained their model with the test set? So the problem is you can't really train your model on the test set because the test set doesn't have labels, right? This was the big difference in the training set up here has all these columns including price. But then when we just looked at the test set before we actually added a price, it didn't have any actual answer. Yeah. But no, we can do. I like some graphing. I could do just a little bit on, and actually this we actually will touch tomorrow. But I will throw out. What if we go back to? Let's see. Let's go to code. Oh yeah, y'all, upvote all my notebooks. Give me medals. Let's go back to our Python crash course. And if we scroll down, that's my favorite things. Let's edit. Okay, this is a great question. So you asked, why didn't I need to use .copy on setting test price? Actually, we'll answer this because this is a little bit more relevant to the problem at hand. But then we'll still have some time to do graphs. So the difference here is that this is actually the original data frame. So you only need to use .copy when you take some kind of slice or filter of it. So like, for example, what if I said, test set, but only where like, home type could be single family. What if I said I want the test set, but only where home type is equal to single family? So this produces something that looks like a data frame. But then if I tried to set something on here, like maybe I say, when it's a single family, I actually think the right price is 200,000. Then I would get this error. So it's only after you've done some filtering that Pandas gets upset when you try to update it. But if you use .copy, you'd be in a better place. I hope that answers that question, but I think that's a good question. Yeah, okay, so the truth is I think there actually are, I'm not endorsing this, and this technically is cheating, and if I find out you did it, I will banish you or whatever, but this data does you can go and look it up, and I think there are, I don't know, how big is the data set? The test set has how many columns? The test set has 26,000 columns. So if you want to spend your time looking up the prices of 26,000 different houses, be my guest, I suppose. But I wouldn't recommend it. Okay. Cheating is bad, folks. Yeah. That's it. The front of the t-shirt says relatively nerdy, relatively fast, and then the back of it says cheating is bad. There you go. Okay. We have just a few minutes to do a little bit of graphing. So I guess the first thing to look at is there are lots of different graphs you can make, right? So here's one. Let's try. I'm going to import NumPy. Also, we're entering this is sort of the random section. I will say the formal little piece of the live stream has concluded. Thank you so much for being here. We're going to sort of devolve into some more nerdy things that I think are useful. So feel free to stick around. But if any of this confuses you, like, really don't worry about it. So we can import NumPy, and one thing that NumPy has that's really nice is you can generate random distributions. And I believe we could do like a normal distribution, which, don't worry, I'm getting there. And yeah, let's just say normal, and then size is 100. So we're getting 100 random data points for X, and then 100 random data points for Y. And then, so we already did our plot, like plt.plot. But you can also say, import matplotlib.pyplot as plt. So we could just say plot x, right? And that'll give us a weird looking graph because it's random data, right? But we could also do scatter. Actually, let's do hist. So hist does a histogram where it shows you how many data points are in each bucket, right? So this is kind of another fun one. Where we can see a lot of our numbers, because it's just randomly in a normal distribution going about 0. You can see, okay, yeah, like this is a bell curve, right? Most of our values fall around 0, and some of them fall around -1 and 1, and a few of them fall around 2 and -2, right? And we could do that for y as well if we wanted to. We could say plt.hist y, and we would get 2 different ones, and it actually does color coding for you for free, right? And so you can see they're roughly the same. But if we wanted to look at both of these sort of with an x and y, we could actually say plt.scatter, and we could have x and y, and boom, we have a scatter plot, right? But what if we actually had 2 different distributions? I'm just kind of spewing here, right? I'm just coming up with stuff. So maybe we could say x prime and y prime, and here. I think you can say location equals, let's say, 2, and scale is 1.5. And then location here is 2 as well. So now we have another distribution where we've kind of messed around with where the data is coming from. So we could do that, and then we could also plt scatter, and we could say x prime and y prime. And we could put in, oh, come on, help me out with the autocomplete here. Oh. Yeah, I think just C, you can pass a color. And so one way you can pass a color is RGB. So if I said, what if I want these to be red? I'll say R is 1 and G and B is 0. So you can see we have our red data over here, and we have our blue data down here. Which, oh, that's interesting. Okay, it doesn't like that. Well, I think you also can just pass a string. We could just say red. Cool, it likes just red. So now we have that graph. Now, what if we want to give our graph a title? We can say plt.title, and we can say the reds versus the blues. And there we get a title. But what if we want the font to be bigger? We can say font dict, and then I think we can just say size. So we're passing a dictionary, and we can just say size 40. Boom, so now our title is big, great. But what if we want an X and a Y axis labels? Well, we could say plt Y label, and maybe Y is height. Maybe we're measuring how tall people are, and maybe our plt X label is how old they are. So does being older make you taller? And okay, we have our height and our age. I guess we probably say age, right? Okay, so there's just like a random, I just spewed a few like random things to make your graphs look a little bit nicer. We looked at histograms, we looked at scatter plots. Hopefully that gave you something to play with. And yes, I absolutely will play the Kalimba. Hayden Crystal asks, what are we supposed to submit after this session? So I will say, ultimately, to actually participate in this competition, all you have to do is by the end of Friday, this runs until Friday, all you have to do is submit one notebook that actually contains a submission. And that will, you will have participated in the competition. To mark that you have been here, all you have to do is go to this registration and make sure you check in. And then the final thing that I will say is that I am offering 5 little prizes for folks that are participating in this competition. And the 5 prizes, I think this worked well last time. The 5 prizes are, if you are, I'm curious actually, has anyone submitted yet? Has anyone gotten on the leaderboard? No one's gotten on the leaderboard. Which you could do if you wanted to, just by going to submitting and just click. You just go here, click copy and edit, and then click submit, and you can get on the leaderboard. But so the five prizes that we're offering, they're all swag drops. One is for being first place on the leaderboard at the very end. The other prize is for being second place on the leaderboard. The third prize is I will just raffle it randomly to someone who made a submission. So even if your model isn't that great and you didn't get that good of a score, I will randomly pick someone who submitted to just receive a swag drop. And then the other 2 prizes are for someone that publishes their own notebook, so the best notebook that somebody from the community publishes, and then for the best discussion that pops out around the discussion page. So if you have a really interesting insight or question, you can come and create your own topic and people can engage. Or if you have code that you'd like to share, you can always publish it and it'll show up here along all of my notebooks. User Sandra asked how to join the competition, and that is a pretty simple one. If you go to this URL, and actually I will go to see hopefully what you see. You can click join competition right here, and you'll have to sign in. You'll have to create a Kaggle account, which is, part of the deal. But then once you do that, then you'll be able to clone any of these notebooks and use them to submit, and hopefully try to build your own model that's smarter than mine. And we'll get deeper in onto how to build a cool model sort of next time. But part 1.5 on submitting kind of gives you the basics on how to actually participate. I think on that note, we are about to get kicked off stream, but it has been an absolute delight having you here. I think the level of nerdery on Python, this is pretty good. This is, I think, possibly like the session the intro to Python session that I've enjoyed the most, because there were like a lot of engagement. So I really appreciate that. Skull Crusher for life. The question. Skull Crusher for life. You've been bringing it with the good questions. You said we could submit 10 times per day. Is our submission our best result, or do we have multiple chances to see how our changes stack up? Yes. So this is a great question. So you can submit 10 times a day. And by default, I think this actually says it over here. Let's see. Maybe it doesn't. So there's when you submit, and my view looks a little bit different, but when you submit, you actually get to pick 2 submissions that you want to be counted as like your actual score. So you actually don't have to pick 1, you can pick 2. And if you don't pick them explicitly, they will be whatever 2 submissions you have that did the best. So usually you just don't have to worry about this. Like, try as hard as you can, try to build the best thing you can. And then whichever 2 of the best ones will be the ones that actually score on the leaderboard. You answer yourself here. I think last time I had it at 5 submissions per day, and like I basically just want to let you do it as much as you want. So I upped it to 10, which hopefully is enough. Yep. All right. On that note, unless there are any other questions, I will play us out on Kalimba, and we will call it a day. Okay, yes, there are a few more questions that I will get to, and then I'll actually sign off, even though we've already done our calming music. So for me, you do not have to submit on DevPost. I know sometimes for other Global Hack Week things to get points or something, you have to. So I would say for my purposes, you don't, but there might be other reasons that you want to. I think the energy was great tonight, which I really appreciate. Yeah, I can show you how to do. I think I actually showed it at the very beginning, but if we go to discussions, yes. So we already have one. I'll give you an upvote there. Let's see, deep insight. Soup is nice. Love that. But you can click new topic, and you can enter in whatever name for your topic you want. If you have a question, it kind of prompts you there. And then, of course, you can see other people's deep insights, and you can respond to them if you want. And I can say, yes. Radical. I love Avatar: The Last Airbender as well. Ooh, okay, this is totally tangential and really has nothing to do with this at all. But I love Avatar: The Last Airbender so much. I created a game, a card game loosely based on like the magic system in Avatar: The Last Airbender, where we have like airbending, and we have water bending, and we have fire bending. Oh, there we go. And we have earth bending. Boom. Because it was stuck in my head. It's in playtesting and we're figuring it out. Yeah, this is not real. But I'm so glad it sounds good to you. Hey, if I can figure out how to balance it correctly, then maybe we'll do a Kickstarter or something. Oh yes, feel free to connect with me on LinkedIn. I can drop my LinkedIn. I mean, you can search for me. Will Liffert. Boom. You can find me. I mean the show. That's what I mean. Yeah, I'm cautiously optimistic about the new live action one, but we'll see. All right, so good to see you all. I'm about to get kicked off, but it was so fun hanging out. And I will see you all tomorrow. I believe an hour later than we started today. I'll see you then, and we'll do more analysis and building models and have a general great time. Thank you so much for being here, and happy hacking, y'all. See you tomorrow. Bye.